Hey everyone, my name is Zach. Excited to be here at the Data Team Summit. Thank you to Solution Monday for organizing this and having me and the Anomalo team here. My name is Zach again. I'm a solution engineer here at Anomalo. What we do at Anomalo is we're a modern data quality platform that automatically detects anomalies in your data and finds the root cause. And what I'll be going over today is unlocking better data quality with machine learning and visualization and how we'd implement that across an enterprise data warehouse. So a bit about me. My background is in data engineering and analytics, BI. My previous position was at Tableau as a solution engineer, in which I spent a lot of time doing visual analytics, and at Capital One as a data engineer. So let's get to it. Before I get started, feel free to ask any questions in chat. We'll have people answering as well as myself. And for this demo, for the first half, we're going to be going into what about machine learning and visualization makes data quality monitoring so much more powerful. And then for the second half, I'm going to go into an actual example of this, a little bit of a brief demo. So here we go. And by the way, afterwards, there will be a booth that you can access, and feel free to stop by if you have any additional questions that you'd like to go through. So where can data anomalies occur within my data warehouse? So at the very top of my data warehouse, all the way upstream, this is where I would ingest my data. And a lot of issues can occur here. So they can either occur at the source, wherever I'm getting my data from, or they can occur at the ingest. So maybe a data pipeline issue happens and the data just never arrives in my table. But data issues can also occur at the enterprise data warehouse level. And so this is particularly bad because this is my source of truth. This is where end users, such as BI analysts and data scientists, ML engineers, are accessing data in order to do analytics and make data-driven business decisions. And having anomalies here can be very problematic. Beyond that, they can happen within data transformation stages. If I have ETL processes or I have business logic that is implemented incorrectly, those issues can also originate here. And then even all the way downstream, issues can originate within ML models. Maybe I've trained my model on the wrong set of data, or within a BI dashboard, I could have calculated a metric incorrectly, and anomalies can originate there. So where should I monitor data quality? Given that issues occur all over the place, I would want to monitor them right here at the data warehouse level. And the reason being is this will be able to catch issues that are coming upstream and at the warehouse level, which will segregate those issues from downstream, where the analysts and ML engineers are doing their work. So if there's ever a data anomaly that occurs downstream, the users will know that that's end user generated, and they don't have to worry about tracking something that's coming upstream. So what do we need in a modern data quality platform? Ideally, I'd want something that is going to be simple to use so that lots of different types of users can use it in an intuitive way without having to know too much or be too technical. I'd also want it to be intelligent. And what I mean by intelligent is I'd prefer a system that can automatically detect issues for me, so I don't have to configure checks for every single type of anomaly that can occur. And the reason being is I don't know every anomaly that can occur. And then finally, I want this to be automatic. If I have to monitor hundreds of thousands of tables across my enterprise data warehouse, I'd want it to be something that can do that in a scalable way. So first, we'll go into simplicity. And we have this visualization here to represent it. Very simple to read. I could see that my metric kind of goes up and down with this trend here. And then all of a sudden for yesterday, it shot up. And this is very clearly an anomaly. So I'm going to go into a quick exercise. Right here, I have a grid of numbers. And what I'd like you to do is try to count the number of nines that occur within this data structure, because the nines are the anomalies here. So I'll give you a few seconds. All right, time's up. So how many nines are there? There are 8 of them, and they're all highlighted in red. Don't worry if you weren't able to count them all in the time period. It wasn't too much time. And don't worry if the number was higher or lower than what you actually counted. The point of this exercise is to show that humans are visual creatures. And for me, it's a lot easier to count up the number of nines when they're differentiated in some way. And here the visual cue is color. So it's very easy for me to go 1, 2, 3, 4, rather than scanning through every single number here. Now, beyond that, there are other indicators that I could use to quickly arrive to an answer. We just went over color, but another one will be distance. Here, I've got the number or the different numbers that are occurring within my grid and the number of occurrences for each number. So for example, 9, I'm seeing the color is drawing me to this particular value where my anomalies are. I could see very quickly that there are 8 occurrences of the number 9 having. So I don't have to count every single value within the grid, nor do I have to count every single 9. I could see the answer in this one-dimensional line right here. So when we talk about ease of use and simplicity, we want to make sure that visualizations are being used so that lots of different types of users feel like this is a tool that would be accessible to them. So what types of users do we have along the data stack? We have analysts, people working within dashboards like Tableau, Looker. We also have data engineers. So these would be users that might be responsible for ETL flows, creating data marts, doing business logic, and then data scientists who are involved in the ML and modeling. Now, the actual ecosystem isn't going to be this segregated and this siloed. We could have lots of users involved in the same area. So, for example, in the world of BI and analytics, we've seen a very big shift over the past 10 years from a place where BI is managed by central IT, and those would be the Cognises and Bob J's and Crystal Reports of the world, over to a blend of self-service and these modern platforms like Tableau and Looker. So we're seeing users in lots of different places contribute. Now, what we're trying to do, what we'd want to see in a modern data quality platform is we'd want to see that same type of democratization and self-service capability so that all users would be able to contribute, anyone who works with data. Now, different organizations might want to manage this in different ways. Maybe some analysts would only care about getting alerts, but they wouldn't want to create their checks. But if they were to create their own checks, they'd want to do it in a no-code and simple way. So we covered how visualizations can make it really simple for users to be able to be involved in data quality monitoring. But we also want a platform that's going to be highly intelligent. And by that, I want to use unsupervised machine learning to detect the anomalies that I wouldn't know to look for, my unknown unknowns, as well as a way to go through a root cause analysis in a way that I don't have to do it on my own. This is already provided for me. So there are going to be a few different categories of checks. One would be validation rules. And historically, this is probably the category that a lot of users are familiar with. Validation rules would be things like, I care about every single value within a record or a column. Maybe I want to make sure that the values are never null in a column, or they're always unique. They're never duplicate values. But these are very granular, and they can be really brittle. They're not looking at a high level. And as my data changes over time, they can create a lot of false positive alerts. Metric anomalies are going to be another type of check that users will be really familiar with. And these are aggregate level checks. So as a business user, I might care about certain KPIs that are going to be important to me, such as my average number of tickets over time that I'm selling in a business of shows and concerts. I'd want to track that over time. So here I will get these overtime visualizations, and these can reduce false positives because if time series models are implemented, those models will change with the data, and I won't be alerted unless there's an extreme anomaly given the context of how that data changes. Now, that being said, these two are what we're used to seeing in legacy data quality tools, and these can be really helpful. However, I won't be able to scale them in an enterprise warehouse. I can't write hundreds of these checks for thousands of tables and manage them over time. I'll be getting a lot of false positive alerts, and it'll take a considerable amount of time for me to manage. So that's where unsupervised data monitoring comes in. And this is going to allow me to automatically detect anomalies and find the root causes before anyone else. And this is going to be catching those unknown issues. So visualizations make data quality monitoring very simple, and unsupervised machine learning makes data quality monitoring very intelligent. We're catching all these significant issues. The last part of this is I'd want a modern data quality platform to be automatic. It needs to be scalable if I'm monitoring thousands of tables. And alerting is going to be a part of that. I need the option to route different alerts to different notification channels. And that could be across different tools like Slack or PagerDuty or Microsoft Teams, as well as to different teams. Certain teams might care about monitoring hundreds of tables. Maybe a team of data engineers want to make sure that a bunch of ETL pipelines are always working. Whereas maybe I'm on a business analyst team and there's only 2 tables that we use every day. And maybe there's only certain key metrics that I care about. I only want to get alerted on those so I don't have to scroll through a bunch of other alerts. So how do we make this automatic? Well, one, I need to have good coverage. As soon as I say I want to configure a table, Anomalo or this modern data quality platform should automatically start monitoring my data without any specific configuration. And then I want to be able to get alerts on issues that are found. So if Anomalo is going to be monitoring my data automatically, if it finds an alert, I need to be notified immediately. And then finally, in that modern platform, I need a way to resolve issues quickly. If I find an issue and I'm spending too much time trying to figure out why that issue is occurring, then I'm still spending too much time in a place that I don't want to. Maybe I'm an analyst and I want to be doing analytics, but I find that over half of my time is actually spent towards resolving data issues. So that is where a root cause analysis feature comes in handy. As long as it's automatically generated, that will save me that time. So last thing is, among these 3 different types of data quality checks that we went through already, I might be tempted, if I want to use all 3, I might be tempted to think of this from a perspective of, let me start with validation rules and metric anomalies, as I'm used to doing, and then supplement that with unsupervised data monitoring. And this way I can cover everything that I'm already covering. And then on top of that, I would be able to catch those unknown issues. But that's still under a similar legacy paradigm where I would have to create hundreds or thousands of rules across an enterprise warehouse. So under a new paradigm of a modern data quality platform, I would actually start with a foundation of unsupervised data mining. And so this is going to cast a really wide net and automatically detect the significant issues so that I don't have to create custom checks to find all of those. Now, that being said, there's always going to be a time and place for these. I don't want to underappreciate these types of checks, but I might only add these for the things that are very business critical to me. So in summary, the 3 pillars of a modern data quality platform that I would care about are going to be one that's simple, and that visualizations make it really accessible and users can self-service. I would want it to be intelligent so that the unknowns are caught. We don't have any blind spots. And it also needs to be something that is automatic and will scale with my warehouse. So let's hop into a demo to go over what this looks like in practice. So here I am in Anomalo, and right now I am monitoring a fact listing table. And what this table contains is ticket sales data for shows and concerts in the United States. And the first thing I'll see is 6 different categories of checks. But before I hop into those, I want to take a look at this visualization down here. And what this visualization is showing me is a profile of my data. So I'm getting a list of my columns, and within those columns, I get a distribution of the records. So for example, within my venue state column, I could see that it's quite common for venues to be located in New York and California. So this is just helpful if I'm a data engineer and I have to monitor hundreds of thousands of tables. I might not be able to be an expert in every single one, and this will help me get oriented around that data, I should expect to say. So heading back up, these first two categories of checks, I'm first going to be using machine learning to automatically determine if my data is arriving on time. And if it isn't, then I'll be getting a notification for the SLA I set. In this case, it's 6 a.m. And then data volume, where I might be seeing that some records are arriving, but I need to know if all those records are arriving. Is my data complete? So here Anomalo is going to be using a type of machine learning, and it's going to be pulling a count of the number of records on a daily basis, going back historically, plotting it over time, and then generating a time series model. And what this model is doing is predicting the confidence interval on any given day and the range between which the number of records loaded should fall between. It looks like yesterday it was at 2,300 records. So this is right down the middle. But a few months ago, I would have had an anomaly occur. And so I would have gotten a notification. So here is an example of both using machine learning and intuitive visualization for me to track data quality issues. Now, after these first two checks, which are just going at a shallow level to determine whether my data is here, Anomaly goes into unsupervised machine learning, which is trying to detect if there are anomalies within the data itself. And there are two different types. Missing data, where Anomaly is going to be looking for significant increases in missing values or missing records. So, for example, I might care about if nulls increase, I want to know. Or Anomaly would look for increases in zero values or empty string values, NAs, and unknowns. This one's pretty interesting, drop-in segment records check. So what this is doing is, let's say for my data volume check, the total number of records isn't changing much day to day. There's not really a significant drop for yesterday's data. That might not be telling me the whole story. So coming down here, what Anomaly is showing me, or what a segment record check would be doing, is, well, what's a segment? In my category name column, pop would be considered a segment of the data. So let's say pop normally doesn't have a lot of variance, but the number of records suddenly shot down by 30% for yesterday's data. Anomaly would say, hey, I'm seeing that the total number of records in my table hasn't really changed much day to day, but this one segment really has shot down, and this is an anomaly. Now, it would also give me additional context. It could be the case that plays increased by 50%. So maybe these pop records were misattributed to the wrong segment, or a new segment could have been added. An anomaly could be pointing at the fact or hinting that it could be possible that this one segment was subdivided into multiple subsegments. So we're missing data is using unsupervised modeling to detect whether data is missing. Table anomalies is going to be doing the same thing, but to see whether values change in any significant way. Now, I'm going to be going into this in detail in just a bit, but brief overview, this is the model that is going to be looking across my entire table, looking for any drift historically. And why this is so important is, let's say I'm a data engineer. I don't want to have to write hundreds of thousands of checks. That'll be very difficult for me to manage. But let's say, for the sake of an example, I'm already doing that and all checks are passing every single day. Even if that is the case, there still might be anomalies that I wouldn't know to look for. And those are going to be my unknown unknowns. So not only is this going to help me in reducing the number of checks I have to write, but it's also going to be catching significant issues of anomalies that I wouldn't have known to write a check for. And again, we'll go over this in detail in just a bit. So all four of these categories are going to be completely out of the box, automatic. So as soon as I say, hey, I want to monitor this table, they're going to run. And this is going to help me scale to the level of an enterprise warehouse. Now, that being said, there might be a time and place where it's important for me to create a custom check. There might be certain business metrics that are really important to me. So Anomaly gives the option for two different categories of checks. One would be key metrics. And key metrics are going to be things like KPIs, things I'd want to measure over time with time series models. These could be sums or averages. So let's say I am a business user. I'm not too technical of a user, but there is a certain metric that's really important to me, and that's the average number of tickets that I'm selling on a daily basis. So what I would want to do is self-service by creating my own check. And so in this interface, Anomaly is going to give me the option to have over 100 out of the box, no code or low code checks. Now, of course, it will scale with my technical capabilities as a user. I can write very advanced SQL if I need to, but in this case, it's pretty simple, and I just need my average. So I'm going to search for my mean. I'm going to click here. So all I have to do is select my column. And again, I care about monitoring my average number of tickets. So that's all I need to do. I could save it and run it from here. Now, again, I'll have advanced options. Let's say I want to segment my data to be, maybe I want to segment my data to be particularly to a certain area. Maybe I care about tickets being sold in New York, or I care about tickets sold only for customers who spend over $10,000 in tickets a year. I could do things such as changing the confidence interval, make it wider or narrower, as well as adding hard limits to lower and upper bounds. And then in terms of simplicity as an end user, in this case, I'm an analyst. And maybe at the table level, I don't care about getting every single notification. The data engineers might want that. But for this particular check, I might want my own notification. So I could choose a separate channel to have this particular check routed to. I'm not going to select any advanced options, and I'll just save it and run it from here. All right, so this should be done pretty quickly. All right, so we just ran this check, and Anomaly seems to have found an anomaly. Now, what did I ask Anomaly to do? Well, I wanted to track my average number of tickets over time to see if it ever deviates a lot. And Anomaly calculated that metric, plotted it over time, and then again generated a time series model. So it looks like the average is generally around 10, but for yesterday's data, it shot up to over 13. And so I would have received an alert in a tool like Teams or Slack. So this was just done in a couple clicks. It clicks and makes it very simple for me as an end user, both the self-service and create my own check, and with the visualization, also to intuitively understand exactly what's happening really quickly. So the other type of custom check that I could create would be a validation rule. And where key metrics are aggregate level checks, validation rules I would use when I care about the values within records at a very granular level. So it looks like a user has already created a couple of their own. One, they want to make sure that all the values within the list ID column are always going to be unique, and all the values within the list time column are always going to be non-null. If they're ever null, the user will be notified. This one's pretty interesting. This is saying when I multiply column 1 by column 2, it should always equal column 3. So if I head into this check, what Anomaly is showing me here is it's saying, hey, I found 233 records that failed this check and didn't meet the requirements for this equation. So maybe I'm an ML engineer. This is helpful for me to get ahead on. I'm being proactive, and I don't have to train my model on years of data only to find that something looks way off at the end. I'll be notified ahead of time. Now, that being said, I used to be a data engineer, and one of the things that I spend a lot of my time doing is trying to figure out why data anomalies were occurring in the data. Whereas I always wanted to be creating data marts or other data products or doing analytics. Found a lot of my time was dedicated to trying to figure out why issues were occurring. So that is where my personal favorite feature comes into play, which is the root cause analysis. And what Anomaly is telling me here is it's saying 100% of the bad records in my data set, and the bad records are these 233 records that failed this check, the 233 records that didn't meet the requirements for this equation. And Anomaly is saying, do you know what all 233 records have in common? they happen to have a venue state in New York. But at the same time, only 26% of the good records in my data set have a venue state in New York. So this is a really wide differential and extremely significant evidence that my anomaly is originating from the records in this venue state. And I know to address it there. Beyond that, there's going to be some nice app features, such as if I want to see some sample bad records, I could scroll through those or download a sample CSV, even expose the SQL if I want to pull these bad records directly within my query editor. So the last thing I want to go over is we just went through some custom checks, and these are great. In a couple clicks, I was able to give Anomalo something to track, and it would calculate the metric, plot it over time, generate a time series model, detect an anomaly, and then when that anomaly was detected, I was alerted. And then when I hop into the actual check, I get a root cause analysis. And that's all in a very no-code way. That being said, it's still not enough. And the reason being is I want to be able to not have to write hundreds of checks. That's going to be very difficult for me to manage. And that is where this unsupervised machine learning model comes in. So hopping into here, what Anomaly is telling me is it's saying, hey, I found a really strong anomaly. All of a sudden, in my number of tickets column, the value 40 shot up. So this might be related with the average number of tickets going from somewhere around 10 to over 13. And I might want to look into this. So with machine learning, again, Anomaly is going to go directly to visualizing these issues. It wants to make this very simple for end users to understand. And here it's asking, was this issue just occurring for a particular portion of the day? But it looks like it was happening throughout the entire day. And then here I get a tornado plot in which it's saying, what if I took the most commonly occurring values in my number of tickets column and I compared yesterday's data to the data from the day before? Now, for most of these values, the data didn't really change much day to day. But all of a sudden, for the value 40, it went from 0% of the records to over 10% of the records. And Anomaly is saying, wow, this is really severe. This is absolutely an anomaly. Now, the best part about this is it goes into the exact same root cause analysis that we saw earlier. And why this is so important is if I hadn't known to create a custom check for this very specific type of anomaly, and of course, there could be thousands of types of anomalies just in this one table. If I hadn't known to create a custom check for this specific type of anomaly, Anomaly would have found it for me anyway. And not only that, it would have found the root cause as well. So we have a lot of customers that are leveraging Anomaly in this way to automatically discover anomalies and find the root cause, and some of which would be Discover Financial and Block/Square. This is the foundation of something in which we're going back to a platform that will be simple, intelligent, and automatic. And again, in summary, simple because visualizations are provided. I can easily get to insight and very quickly. Intelligent because unsupervised modeling is automatically detecting issues and the root cause is going to be generated. And then finally, it's automatic. I'm getting alerted without having to set much up. Tables are going to be monitored with unsupervised machine learning without any specific configuration. So that is where I'm going to pause. Thank you so much for your time. If there are any other questions, feel free to put them in chat. We'll try to get them answered. And again, feel free to swing by our booth if you have other questions that you'd want answers on in real time. But yeah, thanks so much for coming to this talk.